This is a continuation of our notes on heat and temperatures that we've already been doing. So you should have already seen the earlier slides and also this audio part of those as well. So we're just continuing on that. The basics of heat and temperature. Temperature is just the energy of molecular movement. The concept is simple. The faster molecules are moving, the warmer the temperature. So if we add more energy into a substance and the molecules move faster, the temperature rises. Heat, a related concept, but not the same, is a measure of the amount of energy in a substance, often measured in calories. Heat can also be the flow of kinetic energy between or within substances, by the way. That term is used in both instances, even though it has a somewhat different meaning. But we will focus on, for the time being at least, the amount of energy in a substance, often measured in calories. Specific heat is the amount of heat required to change the temperature of 1 gram of a substance by 1 degree C. Amazingly, we have something kind of easy to learn now that we're in the metric system. We don't have to use the complicated units like British thermal units and ounces of water and so on. We have a very nice system. Here's how it works. If you want to raise 1 gram of a substance of water by 1 degree C, you just need 1 calorie by definition. By the way, a gram is 1 cubic centimeter, which is about 1/4 of an inch by 1/4 of an inch. 0.4 inches by 0.4 inches by 0.4 inches, something like that. So water by definition, then, it takes a calorie to raise a gram of it by 1 degree C. Interestingly, with soil, it takes less than a calorie, maybe about 1/5 of a calorie, depending on the characteristics of the soil, to raise it by 1 degree C. In other words, it takes more energy to raise water at 1 degree C than it does soil, or pretty much almost any other substance. I just pulled gold out of a standard chart on this. I just went online and looked at it. Gold, it only takes about 3/100ths of a calorie to raise 1 gram of gold by 1 degree C. So in other words, water has an enormous heat capacity. You can put a lot of heat into it and it doesn't warm up very much. That's one of the marvelous characteristics that has enabled our oceans to shield us from the most adverse effects of the extra heat trapped in the atmosphere. The oceans are absorbing somewhere a little over 90% of all of the excess heat trapped in the atmosphere because of the additional greenhouse gases we put up there. Water is absorbing that. Pretty amazing thing. So which of the above will warm most with a given amount of energy input then, to see if you're understanding the slide? The answer, gold. Yeah, it doesn't take much energy to raise gold 1 degree C. And so if you put a calorie into gold, it's going to have an enormous response. It only takes 3/100ths of a calorie to raise it 1 degree C. I'm just going to leave it here. We'll do a new slide for the next one.